Hi, welcome to my kitchen table. So we're going to talk about calipers here, right? So we get several. I have no digital calipers. I have these Mitsuo ones, which I don't know how much they would cost new, but they cost me $50 used, bought from a widow of a machinist. Obviously her husband's, who's the machinist. I mean, not that housewives of machinists couldn't have their own calipers. Uh, but anyway, this is an Empire one. So these are all vernier scale ones, right? And I'll talk about these lines and what they mean here. But this is a Empire brand I bought at Home Depot. This is a Husky one. And I actually ended up liking this one a little better because it was more readable, even though I think this one might be made in America. And obviously this is like not the store brand, so obviously it's a little better quality. I don't think much. And then I got these plastic ones. And the story behind these is basically my wife, who's a physical therapist, a doctor of physical therapy. She needed to do some kind of therapy that involved calipers, and she's like, "Hey, do you have calipers?" Because that's like a thing you would have, because well, you've seen my YouTube channel, and she lives with me. Um, and yeah, I'm like, "Do you need like good ones or cheap ones or whatever?" And she's like, "Oh, I need cheap ones." And then like, long story short, I said, I should like actually, you can have one of these, but I'll just get you the plastic ones, because they were gonna go on human flesh, and I basically said, let me go on Amazon and get them, and the other, and then I bought, I went to look for them. When you get the plastic ones, they're all like so cheap, you just, can't, you buy 10 or 7 or whatever, so I just got the big pack of them, because, you can't buy one of them, basically. And all these calipers, and so basically, I'm going to say that one thing I was amazed about, and the thing I'm really going to talk about in this video before I go into calibrating stuff, is, so the main reason I got this was, so all these other calipers measure up to 1/128th of an inch. This goes to 1/1000th of an inch. But the main reason I got it was just because this big dial here, because I don't have the eyes anymore. I do not have the eyes to read a vernier scale. But then I discovered when I got this one, and like maybe at first I thought it was just the contrast. I'm like, I can actually read all these lines here. And the thing with the vernier scale is, so let's actually try to just take a little measurement here, so we can do this. So, okay, I can actually read it through the camera too. Okay, so these are nominally a quarter-inch hexagons. These across the flat, these are nominally a quarter-inch. So let's just take the measurement here in the middle. Okay, and what you're supposed to do, you're supposed to see which of these lines actually, so we know it's a quarter-inch, but see that 0 to the quarter-inch does not perfectly line up. We have to see which of these actually lines up perfectly, and I think it's the 4, okay? And those are 1/28th of an inch, so you have to add that many 28th of an inch to it. Right, so let's just see. So we've got, I'm going to say 4 or 5. Let me go. No, I'm going to say 5 is close. No, I'm going to say 6. Yeah. I'm going to actually say 6. Okay, so I'm going to say 6 1/128th is spot on. Okay, so 1/4. So, so, 1 divided by 4 plus, let's go scientific. Use scientific calculator. Okay. 1 divided by 4 plus 1 divided by 1. Oh, 6 divided by 1 divided by 4 plus 6 divided by 1/28. 0.298, so 0.29875. Okay, let's check this with the better instrument. Now, I don't have the means to calibrate these or test these with gauge blocks or a standard calibration standard, which you would use for a micrometer, which goes to hundredths of thousands of minutes to mils. Okay, so anyway, so this is 0.247. This is 0.247. So 0.247. Okay. So I don't know. I don't know how accurate that is. So anyway, we're gonna do some more. Okay. So we're gonna figure that one out. So we said that 247. So 1/1 divided by 4 plus. I'm gonna just say either 4 divided by 128 equals 0.28. Yeah, so I'm going to say maybe these are not the most accurate. But here's the thing that okay, so maybe these are not super accurate. And actually, I'm going to sit there and say that they don't touch the zero perfectly. They're about level. But here's the thing about these, right? And maybe these are not down to the 1/28th of an inch. Actually, let's go take this again. Okay, so 1/4. Yeah, no, this is on the 6, yeah. 1/4. 1/4 plus 1/1/4 /4 plus 6/128 equals 0.29. So that would be 0.29875. In theory, that should be that, which is much wider than this. So I'm wondering if there's a little flexion on these. But anyway, so maybe these aren't super accurate. But here's what I like about these, and that's why I might actually buy a metal caliper pair. So I realized the reason I could read them is basically, and I'm over-exaggerating. I don't need to use my calipers to measure my calipers here. But this over here, the vernier scale here is much more, in addition to being metal, and I thought it was, because at first I thought it was contrast, and maybe contrast has something to do with it. But the other thing is, like, so this over here is like the distance between the gaps, and this is not going to be accurate at all. Okay. 0.4, 0.47, 0.469, 0.468. Whatever, we'll say that, right? So that's about where we are, right? And let's just lock this in. Let's lock this in real tight. Basically, so yeah, as you can, this is not the full vernier. So basically, this vernier scale. So these vernier scales. So basically these, and I should have looked this up before the video, but I'm sure there was like a Dr. Vernier or a mathematician by the name of Vernier to figure out some crazy ratio. But these numbers up top basically are like are at an offset, and that's why you can line one up to this, and that's how you get from one, even though this only goes up to 16th, obviously. And you can do the similar thing with millimeters on this, which same thing. This goes to 0.05 millimeters. Right, so, and you can do the same thing down here. That's actually probably a little harder to read, but same principle. And so that's one cool thing. And actually, yeah, that's an advantage of this. So these dial calipers, right? So you can get digital calipers, but obviously you can, read in both forms, right? Easily just push of a button, right? Because it's like a computer in there. A dial caliper, like, could never do that. I mean, I guess you could have both numbers inside, but then you could have two numbers in the dial, but, like, it would be a pain with accuracy over there. So yeah, it's just going to be one of the things where it's like just never going to really do that. So that's one disadvantage. But the advantage of the dial caliper, in addition to like just going up to thousandths of an inch, regardless of quality, and because I don't think most of the time, I mean, if you're a machinist, you need that, right? But I really think and you can get vernier scales that go to like a thousandth of an inch, right? You can get that. Actually, let's see what 1 divided by 128 is. 1 divided by 128. Yeah, what is 1/128 equals 0.007, so that's 7/1000 of an inch, right? So if I could go to like, if I just get one more tick on this, I can go to, so, you know, 256, which I could probably do like on a vernier scale that long. So obviously going to like, you can get one that goes to like thous, right? But these are just easier to read, really. They're just easier to read, easier on the eye, right? And also I think with this gear, like it's just a little more like friction to lock down and get, because there's gears in here, and sometimes they skip a tooth. Actually, you'll note they'll skip a tooth, and then I think they end up at like 0 becomes over here. Like you'll have to like actually go recalibrate that much over here. And there's other things to do here. Like there's like, supposed to clean this off, clean that off, right? To do that. But now I kind of want to get a metal set of these, right? I want to get a metal set of these. Maybe, you know, maybe I'll get like with this style where it's not super small like this, the vernier scale where it's wire like this, and maybe I'll get like that in like you know, 12-inch set, right? Because I realize like I can actually read this vernier scale here, and that's kind of useful and handy and helpful. You know, and maybe at that point I'll also like look for a cheap pair of gauge blocks so I can like calibrate these and stuff, because you know, I'm insane because I don't need that, right? But you know, I want to be the guy that has the gauge blocks and the standards, the calibrated scale. That's who person I want to be, and I'm going to live that dream. But yeah, anyway, so these are, I guess, not the greatest. Actually, let's keep on keeping on. So this should be 9/16, right? So that would be 8/16, 9/16, but it's not quite 9/16. It's actually a little under. Oh, actually, wait a second. This was under, right? We said this was. Let's go back. Let's take that measurement again. So we said that was under a 1/4 inch. So it was actually, and it's actually closer to 6, right? So that would kind of make sense, right? So this is actually, let's assume this was actually 3/16. Okay, let's do this. Let's do 3/16 plus 6 divided by 128. And that equals 0.023. Okay. Let's do that one over here, right? And we're going to wipe this. So I saw Mr. Pete like this. He said he wiped these with the finger. He had a calibration video on these. So I'm thinking we're going to squeeze this really hard. Like, we're going to squeeze this really hard. And we're going to say 0.0249. I don't know. Yeah, I don't know. So I guess these aren't super accurate, right? Which is fine. And my wife, and one thing, another good thing about these like calipers that like, you know, these is sometimes you want like that 1/16 inch accuracy. Like when I'm measuring these, I really just want 1/16 inch accuracy. Like when I'm measuring bolts and stuff. You know, but anyway, so this should be like what, 9/16, right? But it's a little under 9/16. I'm actually going to go with 5 being on the money. So 9/16. So I'm actually go with 0.5 plus 5. 0.5 plus 5 divided by 128. This isn't scientific calculator. 0.539. Okay, 0.539. Okay. Let's just take some more measurements here. And this is actually saying 0.4. No. 0.43. So that's saying 0.433. That's saying that's being weird. Trying to look through the camera. Maybe they're just like super not inaccurate. Like, I mean, they're definitely right. Let's go here, right? Did I say 3/16? Wait a second. Oh, I said 0.5, yeah. What did that read? 436. 0.436. So let's just say, so first of all, let's go with 9 divided by 16 equals 5. So that is 0.436, right? And this is, wait, 1, 2, 3, 4, 5. Oh, it's actually 7/16. I'm sorry, 7/16. So 16. So 7/16. Okay, I'm completely screwed up. So 0.4375. So 0.4375, and this is so 0.436, right? That's 0.436. It's between the 4 and the 5 over here. So these are the tenths. That's the 100th, and that the 100 is the big number on the dial, and the dial is the tick mark, right? The thousandth the tick mark, right? Okay, so let's do this again. Okay, so that's 7/16, not 9/16. I don't know what I was thinking. I was not thinking. 5/16. So 6/16. Okay, so 6/16 plus 5. Okay, 6 divided by 16 plus 5 divided by 128. Once again, we are in science. 0.041. Okay. Point 404, right? 404. So that's 404. Yeah, so I guess the accuracy in that is like absolute crap, but on these plastic ones. So what we learned the plastic, the accuracy in these things is absolute crap. Right. But I like this. I like this design, and that's fine. This is fine. And obviously, you know, my wife's measuring human anatomy, and she's not doing microsurgery. Okay. So that's fine for what she's doing. And this is actually fine for measuring both, right? Actually, there's something advantageous to like measuring. This is if you want to like sort like bolt quickly. This is actually really something like this is actually really useful, right? Because we know it's accurate to the 1/16 of an inch. I would get the metal one, but the advantage of this is that's kind of like, you know, you don't want to get like I guess confused by all the extra precision of this, because you want the 1/16 intervals, right? Maybe even if you had drill bits, you're going to 1/64. The main thing I actually find this really good at is when I'm trying to measure both. I don't know if it's metric or imperial, because I can easily, because I can just convert this so accurate. I can convert to centimeters, and they're pretty accurate, right? And I can look at holes and stuff, and this is probably good enough where if I knew like the standard, you know, acceptable variance in a drill bit or a bolt for the outer diameter, inner diameter, or something, I could measure them and do that. But anyway, yeah, I guess the lesson learned here is, yeah, these plastic ones, yeah, not very accurate, but you know, useful to an extent, and I've learned just be the size I'm gonna get. I've seen calipers that look like this, as opposed to, I've seen metal calipers look like this, as opposed to look like that, and obviously they're much more beefier. And I'm gonna look for a pair, and I'm just gonna get one probably just to be cool. Anyway, thanks for watching.